Welcome, everyone. I'm very glad to be here today. Over the next several hours, we're going to try to give you a crash course in Python and give you kind of the fundamental background needed to understand the stuff you're really interested in, the biological simulation that you'll be learning over the rest of the week. So I am a former attendee of this workshop. I was a wet lab biologist in my PhD and in my training, and I learned Python and coding because I wanted to try to solve biological problems that we didn't have the resources to test out experimentally. And I actually got so interested in that I've made teaching programming to newcomers, whether they be biologists or people in other disciplines. It's become my full-time career. So I teach Python at University of Michigan now. So hopefully I'll be able to give you kind of the background that you need here today. So why do we learn Python? Well, so one, it's a very powerful and widely used language. It's in fact the fastest growing language in commercial settings, but it has a lot of libraries where people have built in the functionality to do common tasks that are needed in different communities. And one so that lets you do a lot of biologically relevant calculations and simulations. There's a good way to do reaction. There's a lot of good ways to do reaction network design and analysis in Python. Tellurium is one of them. There's also, you can do stochastic simulations, and there's the StochSS system and stuff like that are really not very complicated once you have just even the very basics of Python because of the libraries. And then the other, which you'll learn about here this week, is CompuCell3D. What you'll learn here this week is CompuCell3D, which is based in Python, but also uses XML and some other setups. But it's designed to make the syntax and make the hard programming parts easier for non-experts. And so our goal here today, once again, is to just give you enough familiarity and fluency to be able to use that tool, which will help you simulate the biological systems that you're interested in. So again, we're going to be focusing on learning the necessary programming concepts, and I will try to, as we go, point out how these are used to do kind of the basic construction of the simulations in CompuCell3D, or give you kind of touch points to look for over the coming week. And then we'll also try to talk a little bit about how you use modeling to understand your biological system, but more of that will come during the course of this week. Today, the real focus is just going to be on the Python syntax. One really important thing to keep in mind is that programming is it's more like learning to cook or learning to do carpentry than it is an academic subject. You just gain familiarity over time and pick up new techniques. No one knows everything about a programming language, and there's always multiple ways to do things, and there's always new things to learn. And so the number one key to success is to have kind of a growth mindset with regards to it. If something doesn't make sense, we certainly encourage you to ask questions about it and make sure you understand it. But there's also some things that can be treated as a black box. Again, your goals, I'm assuming most of your goals are primarily to be able to use this system on the model of your choice. And so there's a lot of borrowing and adapting, and so don't worry if you feel like you can't replicate everything that you see from scratch. It's more about taking something that you see works and adapting it for your purposes. And again, that's one of the biggest benefits of CompuCell3D is even if you don't remember exactly how the syntax works, you'll have little drop-down menus and stuff that will give you starting points and will help you go along on your way. So the first thing we want to do is make sure everyone is in the nanoHUB environment. One second, I'm going to have to. Okay, sorry about that. I was in the wrong set of slides. We're going to have to be in the nanoHUB environment, and which is going to be a web browser based platform that will do all the computing for you, so you don't have to worry about any hardware incompatibility or installation challenges. You'll just be able to run things through that environment, and you can just focus on what you're trying to do. So let's go through that process together first. So go to nanohub.org on your computer, and this is where I am going to try to split screen and do this side by side with you. Okay, so let me log out of nanoHUB so you get the same screen. Okay, so this is what it should look like. You're going to click that sign up button in the top right if you haven't already. If you are a member, you can just click login, but you click that sign up button in the top right, and it's going to take you to a page that looks like this. Okay. And you'll be able to sign on. If you have a US institution, you should be able to sign on here. But all US institutions are represented. Well, not every single US institution is represented, but many are. So you can sign on through there. Alternatively, you can choose the second menu option, which is to sign in with Google. And then through that you can click and choose your Google account. So I'm going to choose to sign in with Google. I'm going to go here. It may register that I already have an account. Okay. Okay. Let's go back. Okay. Well, since I already have an account, it's a little bit different than what you see. Once you choose with your sign-in method, you can navigate to nanohub.org/tools/Jupyter. So you can type that into your web browser, and you'll get a screen that looks like this. So we'll pause here and wait, and the chat will be open for any questions. You will be able to use Jupyter Notebook on your computer, but you will probably want to sign up for nanoHUB for the CompuCell exercises this week, unless you also have the latest CompuCell installed on your computer.
We recommend signing up for nanoHUB regardless, even if you do have CompuCell installed, because it's an easy way to switch over to a guaranteed working version of CompuCell if you do start running into issues with your install. So just having that as a backup would be useful. Plus, there's a lot of cool stuff on nanoHUB, so it's probably worth having an account anyway.
Okay. Let's end the poll and relaunch.
Got a question here in the chat, Bobby.
Yeah, so that's the
Online.
next step. I just wanted to see if
Okay, cool.
okay, there's still some people who need more time. Okay,
So
the
one
easy
thing else, sorry, let me just quickly say one thing about the poll, these exercise polls. You can't undo your response. So in general, when you're done, click done. If you need more time, only click need more time if it looks like the person is going to go on to the next exercise. Because once you click need more time, you can't unclick it. So there's no way for you to say that you're done after you click need more time. If you need help, immediately click need help. But otherwise, we have to go back and relaunch the poll to check for people who need help. So I guess one thing maybe to do is if people who need more time could raise your hands, that would be helpful. Try out the raise hand function in Zoom. Is there anyone who has not succeeded in logging into that at this point? Is there anybody who needs help getting into nanoHUB now?
Yeah, if anyone does, we can open a breakout room for you or something. But please raise your hand or drop a comment in the chat. Okay, well, 23 of 31 have, and that might be everyone who's not a host or close to. Okay, so with that said, again, if you are behind, please drop a comment in the chat and someone will help you directly. But what I'll say is, if you are logged in, I think the easiest way to do this is to just navigate to this website, nanohub.org/tools/Jupyter, and Jupyter is with a Y. And then if you navigate to that website, you'll get a screen that looks just like this. And at that point, I would do two things. First, I would go to collect, which will add Jupyter to your favorite. So next time you log into nanoHUB, it'll be there for you to click on immediately. And then the second thing I would do is go to Launch Tool. So first, I go here to collect. Then I can add it to favorites. And it's signed in. And then the next thing I can do is Launch Tool. And when the tool is launched, you'll end up in a file directory like this. What you can do is if you already have a notebook, you can click on it. But if you don't, and right now we don't, you go down over here on the right to where it says new and choose Python 3. And that will launch a Jupyter notebook for us to work in. So I'm going to relaunch the poll now. And if you can get to this this page, then you are done. I'm going to pull up the PowerPoint so it has those instructions. Okay, looks. Okay. So I want to orient you a little bit here. So this is obviously a web browser. Python 3. You want to choose Python 3. And you'll know if you're in the right one based on what it says there in the top right. Okay. So Jupyter, that has a PY in it for Python, right? So Jupyter notebooks are ways, Jupyter notebooks have the file ending .ipynb. And basically they're ways to run Python in individual cells. So this is a cell here, and I can enter some command and I can run it, and then I can create another. I can create another cell and run it, and then I can run these independently. In a traditional Python script, it will run everything everything that you have written there. So that's the main difference. And you can add, and the traditional Python script is going to be run on your computer. The Jupyter notebooks are going to be, you can run them locally, but you can also run them in these kind of web-based platforms such as nanoHUB. Collab.research.google.com is a good free one for teaching purposes. But obviously for CompuCell, it's going to be on nanoHUB. And as James mentions in the chat, we will use Jupyter notebooks to upload and download files for CompuCell3D on nanoHUB. So it's a good idea to have familiarity with it. So when you want to save, you can save your notebook under any kind of name. So we'll save this as module 1. And then if I wanted to download this, I could download it as a notebook.ipynb. If you download it as Python, it will still work, but once again, it'll execute everything instead of being able to execute the individual components. When you're building out code, it's nice to be able to execute one component at a time as you test out different approaches and solutions. Whereas once it's finalized, the .py is just as good because it's going to run through everything all at once. But we're getting a little bit ahead of ourselves. Let's get into the exercises. Okay, so the most foundational use of Python is just in simple calculations. And calculation. And calculations, calculations can be done just like you're using a calculator, and you have operators plus, minus, / for divide, asterisk for multiplication, and double asterisk for exponents. And then you can enter in, you can execute the cells by, you can execute cells by hitting run or by typing Shift Enter, and you can evaluate expressions in each cell. So let's start with so the other thing that we should mention is okay, let's start let's start by multiplying 3 and 4. So this is pretty trivial. You could do it without Python, but let's just do that so that you have something to build off of. So 3 times 4. So I promised to make the font big. Okay. So I've got 3 times 4 here. I use the asterisk, and then I can do Shift Enter, and then the output that is shown here, and that's 12. Can do 3 double asterisk, which is raised to the 4th. And I can do Shift Enter and get 81, which makes sense. Most often in Python, you're not going to actually type in whatever numbers you're using. You're going to store that information in variables. Well, let's talk about this in the order. So programs in Python manipulate objects. Objects have a type that defines what they do and what their structure is and what they can do. Objects can be scalar or they can be non-scalar. Scalar objects cannot be subdivided. Non-scalar objects have an internal structure that can be accessed. So we'll go over non-scalar as well, but like a good example of a scalar object is like a number. There's not a different part of a number like 3. A list or something has many constituent parts, and we'll be able to show you that. Again, the vocabulary is helpful framework for thinking about it, but it's certainly not something that has to be memorized in order to do this workshop or even to build your own modules. So the scalar types are integers, like whole numbers, 3, 4, 5. You can have floats, which are real numbers, 5.1, 5.2. You can have Boolean values like true and false. And then there's one called a none type, which means that there's just none. And to get the type of an object, you can type around it. And then in this example that you see here, we've set x equal to 5.1. So x is a variable in this case. In Python, you can assign, we call it assigning a value to a variable. So let's do our 3 times 4 again, but this time using variables. So we can say x equals 3. And when this number increases, so I'm going to do it again. So that 3 up there became a 4. It'll become a 5. Oops. That's how many cells have been run. So that just lets you know when that number ticks up, that lets you know that it got run. You didn't miss the button or anything. So X equals 3. And say Y equals 4. So right now there's nothing in there. So it hasn't been executed. The program, what you've typed, the Python environment has not learned yet. Once I enter, I shift enter and get to run, or you can hit that run button there. Those are your two options. Now it's run. Notice I executed this cell once, but it went to 6 because that's telling the order that these things happened in. And that's important because the information in Python, in a Python notebook, gets tracked sequentially. So X was the X was assigned to 3, and then Y was assigned to 4. And so now we have access to X and Y. So we can do X times Y, and it comes out as 12. Now, if I update Y here to 8, this is going to update because now Y is 8. This has been overwritten. Now Y is 8. And so now 3 times 8, 24. The order that this happens in on the page doesn't matter. The order that this happens in on the screen is what, the order this happens in sequentially in time is what matters. Now, if I say X is equal to 9, and then I run this cell again with shift enter, it does 72, even though the X equals 9 was down here. Because again, it's the order that's being indicated in these numbers. It's order in time that things get assigned that matters. An important thing to do whenever you're not sure, whenever you see a code and you're not sure how it works, is to understand what type of object each part of the code is. So I can do type X, and it tells me int for integer. Now, if X was 3.14, I've run that. And now I do type X again, X is a float. And that gives me an idea of what I'm working with. When it's just scalar types, you can probably tell by looking at them. But when it gets to be these more complicated data types that hold a lot of information, that's when it gets really useful to be able to tell what type an object is, and that'll give you clues about what to do with them. So you can convert or cast one type to another. So if you do, so X is now 3.14, and that's a float. So if you do integer of X, it's going to convert it to 3. And Y right now is 8. So if I do float Y, it's going to be 8.0. These types of details matter more when you're working on a simulation and you have specified what type of data there is. So it may not make sense in your simulation so a float, if I didn't specify, a float is just a number that includes the decimal places, whereas an integer is a round number or a whole number. So if you have cells in your simulation, if you have, say, immune cells in your simulation, you may want to specify that only integer values are accepted. So you only have 3 T cells or 4 T cells. You don't have 3.2 T cells, but you may have other things in your system where floats do make sense and should be allowed. You might have 3.2. 3.2 might be the speed at which 3.2 units per second might be the speed at which a certain cytokine is being released, or at which at which one of your cells is moving through your simulation. So there's different cases where floats and integers make sense, and you may have a rule that you can only use one or the other. And so that's why it's important to have those in mind. So obviously, to do more complicated things, it's not just going to be simple addition and multiplication. You're going to have to do more complex expressions. And these will follow all the rules that you've kind of learned, or all the order of operation rules that you've learned in basic arithmetic algebra. So we can do this example here: 5 squared plus 2 squared, and then take the square root of that. Sweet. Just like in algebra or arithmetic, you interpret at the centermost level, and then you go out and it follows that order. So we can do that. 5 asterisk 2 plus 2 asterisk 2. And there isn't a square root button, so I mean, there are in some libraries, but there's not in basic Python. There's not a square root option, so we raise it to the 0.5 to functionally take the square root. And then you have to shift enter to run it, and then that's what you get. Now, when you do an operation like this, the output gets registered there, but you can't do anything with that output. If you wanted to do something with that output, you would need to assign it to a variable. So you can say, and it's best to have descriptive names. So you could say A equals, and then if I want to do A plus 3, I'm able to do it there. Whereas before, even though 5.38, etc. was printed out, I couldn't do anything with that unless I typed that in myself again. Now, A is not a good name. You're going to want to have a descriptive variable name. So cytokine A level, right? And then that variable can be manipulated or accessed later on in other parts of your code, because it's been stored that way. So now I can do and again, these are trivial examples, but as you build out more complex systems, you'll want to keep these principles in mind. So this is a reminder. When you add 2 integers, the result's always going to be an integer. If you subtract 2 integers, it's always going to be integers. Products of integers will always be integers, and division of integers can sometimes be floats. But for sums, difference, and products, if either one of the inputs is a float, the result is going to be a float. So some of that is intuitive, but some of that is just the rule of the system. So if you do 5 divided by, or let's say 6 divided by 2.0, you might think, oh, that can still be an integer because it's a whole number. But as a rule, if one of these numbers is a float and 2.0 is a float, the output is going to be a float. Another thing that we want to another thing that can be useful is this percent sign, which is modulo, which is called a modulo, which just means remainder. So if I do 7 modulo 3, it's a remainder of 1. 8 modulo 3 is a remainder of 2, and 9 Modulo 3 is remainder of 0, right? So the modulo gives you whatever the remainder is. And then the opposite of that, if you just want the quotient, you do double divider sign. So 2 division signs by 3 is going to give you how many times 3 goes into 8 without the remainder being provided. So those are little operations that can sometimes be useful in figuring out how many of something you're keeping track of are available or unpartnered or unpaired or something. Like if you had a bunch of if you had a bunch of receptor subunits that were dimerizing, you might want to quickly check to see how many are left over, how many unpaired ones there are, and you would use that reminder or modulo to do that. Or if you wanted to check how many tetramers could be formed out of those receptor subunits, you might use this division. So those are little things, and again, you won't have to mentally keep track of all of those, but these are just little things to keep in mind so that you recognize them when you see them. Okay, so we've already covered this. Order of operations apply, and it's operator precedence without parentheses. So it goes, you do power first, and then multiplication, and then division, and then plus minus, and it's executed left or right. And then I've mentioned this briefly before, but it's one, if you just do the calculation, that will show up on the screen to you. And maybe that's something you need to sanity check something or to keep track of something. But if you want to be able to use that value, if you want other parts of your program to be able to check on that value and make decisions based off of it, then you need to assign that value to a variable. And a variable name is something that's it's stored in the memory. So the variable, there are some rules associated with variables. They can be named any continuous set of characters, but they cannot begin with a number. So I can do pi equals 3.1415, but I can't do 3 pi. That's an error. Invalid syntax. You can't begin with a number, but I can do, that's totally fine. And then there are some phrases that you can't use and they'll be obvious later on. You can't use as variable names stuff that is already a built-in name in Python. But when we do pi, I can access it anywhere. And it'll always have, it'll have that value until it gets changed. Okay, so now we're going to start to get into some meaningful stuff, some rules that are maybe not perfectly intuitive. And so let's put this code into one cell. Pi equals 3.14, radius equals 2.2, area equals pi times radius squared. So let's do this, and then we'll run it, and then let's see what area is right now. So right now, area is 15.197. Now, if I update if I update the radius, so now the value of radius is 3.2. Originally, when area was canceled, the radius was 2.2, and now the radius is 3.2. If I check my area variable, it's still 15 and change, just like before. And that's because updating radius does not update the value of area. These are all set. Now, if I recalculate area by saying area equals pi times yeah, if I recalculate it by typing all that up, radius area will update. Similarly, so actually, let's do that just to drive it home. Yeah. So area is now 32.15 because the radius is larger. But if I go back up here and run this cell again, area is once again 15.197 because radius got rewritten. So that's just something to keep in mind. Whatever the most, any given variable will have the value that it had when it was created until that's it specifically updated. Are there any questions about that?
What's happening with the counter? That number
what the counter is
appears in the square parentheses.
Yeah, so that's just to let you know how many cells have been run. And it doesn't matter how many cells have been run, but it helps you keep track of which is the most recent one that's been run.
Okay, cool. Thanks.
So what? Oh, okay, yeah. Okay, so whoever needs help, if they can send a direct message to Hayden in the chat, I think he can, or if you have a question that you want to ask overall, that would be fine too. Okay. So we've done a lot of pretty basic stuff so far. What I want to do now is go over some of the different data types that can be used in Python. So the first of these is called a string. So far we've worked with variables that have numbers assigned to them. And it makes sense that we're going to have to keep track of how many cells there are, how much cytokine there is, how much, there's obviously quantitative variables that we'll have to keep track of. But there is also textual information that we'll have to keep track of. We might need to keep track of cell types or cell states and stuff like that. And the way this is done is through strings. So a string is anything that's enclosed between quotation marks. It can be enclosed between single or double quotation marks. It just has to be consistent between them. So message 1 equals hello there. Yeah, message 1 equals hello there. Okay, that's losing vertical space doing that. And then I can do message 2 equals hi again. And notice this has single quotation marks. And when I run it, it's totally fine. But then when I do message 3 equals double quotation marks, followed by a single quotation mark, that's going to throw an error. Syntax error, end of line while scanning literal, and it points that this doesn't match with this. So that's a frequent source of error. So just for the sake of consistency, it helps to do just one of those. Strings can be concatenated. So we can do message 1 plus message 2. And it just literally attaches them to each other. So oftentimes what you need to do is include a space when you're attaching them. And this could be M3 equals, and then I can show M3. So enter, enter. And so now there's actually a space that makes sense. There are some operations you can do on strings. You can do M2 times 3. There's no M2. So I got a name error here, right? And that's because M2 is not defined. There's no M2. This is a frequent source of errors. I meant to do message 2, but because I had an M3, my brain assumed that I was using that same format before, and that variable wasn't there, so it created an error. But if I do message 2 times 3, it prints out 3 copies of the string over and over again. Now, so far, because we're in Jupyter Notebooks, we've just been having the output show, but we want to get into the habit of using print statements. We want to get in the habit of using print statements because in the CompuCell framework, only what we ask to get printed is going to get printed. Just the regular output will just be internal to the program. So we want to get in the practice using print statements. Print can have anything that's inside of the parentheses. It will print, whether if it's a variable, it'll print whatever the value of that variable is. Remember pi approx. So if we do print pi approx, it's 3.13. And you can also add text. So pi is approximately and this pi is approximately 3.13. And so that is useful when, say you want your program to print out the number of B cells after every 5 seconds or after every 5 units of time. You may not be able to keep track of it unless you add the print statement, number of B cells, and then you put out whatever your variable is for the number of B cells. Print that out, and then that way you can kind of monitor, is the program doing what you think it's going to be doing? Finally, or not finally, but one important thing to do is, so far we've worked with text variables and numerical variables, but the reason we keep track of this information is often because we want to be able to have our system do different things based on the value of different variables. If there are more of cell type 1 versus cell type 2, we want X to happen, but if there are less, we want Y to happen. That's how real biological systems make decisions, right? Or if cell type 1 is epithelial, we want it to act this way, but But if it is mesenchymal, we want it to act this way. The way we access that is through conditionals in Python, comparisons. So if we remember X, let's print X, and then I print the value of X, and then I print Y and the value of Y, just to remind us what X and Y are. X is 3.14, Y is 8. So I can do a conditional and see whether it's what the situation is. Y greater than X. And that is currently true. If I do X greater than Y, I get false. And you can do greater than or equal, still false. You can do message to equals. If you do the double, if you can do the single equal sign, you're updating the value. So, oops. So I'm doing message to equals epithelial. So now I can try message to double equal epithelial. The double equal means it's testing. Is it true? And it's true. If I say message to is mesenchymal with the double equal, it's false. So what this does is, and then I can say, I can also do with the exclamation. So this is not equal to. If message to is not equal to mesenchymal, which is currently true. So what basically all of these conditionals are ways to give directions to things in Python based on the value of something. So we can say every cell that is not mesenchymal should do this, should grow at this rate, and every cell that is mesenchymal should grow at this rate. So that's how that can work, both with qualitative variables with these equal signs and the not equal sign, with the equality and inequality, or through these comparisons for quantitative variables. So let's show other ways that works. The other thing to keep in mind is you can combine these, right? So if you say A and B, so let's do an example here. Okay, so I've just defined 3 variables, one called cell 1, one called cell 2, one called cell 3. The first 2 are epithelial, the third is mesenchymal. So I can say cell 1 and cell 2 equals epithelial, and it's true. Cell 1 and cell 2 not equal to mesenchymal. Oops. So this syntax error, because it scanned, it didn't see at ending for the end of line scanning string literal. So I didn't have the quotation mark to end this. Now that I've updated it, cell 1 and cell 2 is 3 is true. So if I do cell 1 and cell 3, it's going to say false because cell 3 is mesenchymal. But if I do cell 1 or cell 3, it's true and it says which one or what the other value is. If I say cell 1 or cell 2 is not equal to mesenchymal, yeah, it says what they are. Cell 1 or cell 3 is mesenchymal. Oops. Yeah. So it knows that it's true, but it's spitting out which ones are not there. And you can also do not in the same way. But anyway, these all make sense when you do condition control flow branching. So basically, this is what I've hinted at so far. You can have things do, you can have things, you can have different parts of your program react in different ways. So if, and then have some condition. So this is not real code, what's here, right? Condition isn't something, expression isn't something, but those are the names for what we have. So we could say if cell 1 is epithelial, use growth rate of 3. And if cell 1 is mesenchymal, use growth rate, or yeah, so here, if you look at this example, if cell 1 is epithelial, growth rate of 3, else growth rate of 2, or something like that. So you can do ifs, which just have so you just have something execute in response to the condition. You can have if else, which means everything that meets that condition responds in one way, and then everything else responds in the other way. And you can have if, elif, and else. So if one condition is met, you respond in another way. But if that condition is not met and a second condition is met, so elif means else if. Elif, a second condition is met, you get a different set of commands. And then finally, else, for everything else, you get a third set of commands. And you can have as many elifs as you want in a string. So you could have 15 sets of commands for 15 different conditions. The key is that these things are indented, and indents in Python are very important. That shows how that shows what code goes together, basically. It's how you denote a given block of code. If you look at this example, you can see that there's nested conditions, meaning if X is Y, you print X and Y are equal, and then you follow this indentation if Y is not equal 0. So if it meets both of those conditions, then this also gets printed. But once it stops meeting those, it goes down, it checks this. So if X isn't equal to Y, then it checks over here. Is X greater than Y? Print X is, or sorry, is X less than Y? Print X is smaller. Else print Y is smaller. And then finally you print thanks at the end. And this is all set up by the indentation. If, elif, and else are all at the same level of indentation, and then the code to be executed inside there is at a given level of indentation. So let's go ahead and enter this into one of our cells. So when you hit enter, it automatically indents for you if it's after a colon. So in this print statement here, we have some explanation of what's about to be printed, and then comma, and then we do the operation XY inside the print statement. We do that division inside there, which is totally fine. And when you hit enter after there, it's going to want to indent at this level, but you're done with this block. So you just have to hit backspace, and you're actually done with this block. So you have to hit backspace again to get to the level you need it to be. Okay, so we've got this block here. Let's remind ourselves what X and Y are right now. So we can do that with print. X and Y are so X is 3.14 and Y is 8. So based off of that, do we understand what's going to get printed here? So Y is 8, Y is bigger. So it's going to print X is smaller, and then it will print thanks when I run this. And if I change X to be equal to 8. So now both X and Y are 8. Now when I run this, it prints X and Y are equal. And since Y isn't 0, it also prints therefore X divided by Y is 1. And then it prints thanks. Any questions about that? Okay. So for the next 5 minutes, I know we're a little bit behind, but I think we'll make up for it in the other ones. Why don't you guys try this exercise, and then we'll do it together. And if anyone needs help, not about this exercise, but if anyone needs help on anything we've done so far, please direct message Hayden or myself or something, or post it directly in the chat. But yeah, why don't you guys spend 5 minutes trying to do this in your cell? Sorry, in your notebook. Okay, we launched the poll for this exercise. So let's see where you guys are on the exercise. Whoever needs help, please feel free to say something in the chat to either me or to Vanel or Hayden or publicly, and we can either take you to a breakout room or we can just address it in the chat.
I actually have a student who needs help with the Jupyter app, but I don't seem to have a breakout room made for me.
Okay. Let me, I can probably put you in there. Can you message me the student's name? I can put you guys both in there, I'm guessing.
Yeah.
Okay, I think I've assigned you both to that room. I don't know if that worked. Okay, quickly, we'll do this exercise together. We'll use the X is currently 8. So if X %2 equals 0, and remember that percent, that modulo gives you the remainder. And then I'm just going to throw a print X in here just so that we can mentally tell if it worked right. Yeah, so X is even. Now, I'm going to show you something else. So there's a built-in function in Python called input, which will print whatever text is there and then ask for a user input. So now I can test to see if this works for everything. So it's asked me to enter a number and I'm going to enter 5. And so what happens is X is a string. The default for input is string. So we need to have it actually be an integer. Okay, so let's try this again. Now that I've converted the string into an integer. And it prints X is odd. Okay. Now for the extras, it says if X is a multiple of 4, print out a different message. So there's a couple ways to do this. Multiples of 4 is more restrictive than even, right? So it makes sense to test the more restrictive one first. And instead of an else, because I still have to evaluate whether it's divisible, whether it's an even number or an odd number. So I do elif. And then finally, I can do else. So let's try this with 12. 12 is a multiple of 4, and it prints 12. Let's try this with 14. 14 is not a multiple of 4, but it is even, and so it prints 14. And then we can test it on 9. Okay. The second one, in the interest of time, I'm not going to do the second one, but if anyone has any questions, please ask me about that one in the break. Dividing evenly uses the same concept as modulo, and it's actually a simpler one than the other one. Any questions about that right now? Okay. If not, I want to talk about while loops and for loops. So far we've done if statements as part of our conditional, but there's also a way to do something called a while loop, where as long as while, meaning while X is true, or as long as X is true, evaluate these expressions. So this allows you to repeat it. So it runs the expression, it checks the condition again, then it runs it again and again and again and again and again, and repeats until the condition is false. So let's do a quick example of a while. So remember, right now, X is 9. While X is less than 15, print X so X is 9 right now. If I do this, if I were to run this, this would go forever. So this is a bad example of a while loop. Wait, hold on. X2, sorry, because X was a string. While 2 is less than 15, print X2. So X2 is 9, remember? X2 is the integer version of X. So print X2, X2 is 9. So if I do this, it will literally go forever, and that's bad. So a good while loop has some condition that can be met. So when I do get in that situation, I can hit this box to stop. That interrupted it. That interrupted the kernel, and that got it to stop. So you see this number null there's a number here for 83. So I'm going to do that again and hit run, And this asterisk means it's still running and running and running and running and running. So I need to stop, and I interrupted there. Okay. So this is a bad example of a while loop because it doesn't have a condition that can escape it. What you should do is x2 equals x2 plus 1. So now it's only going to run a finite number of times, and it'll check each time. 9, 10, 11, 12, 13, 14, then it stops because it's no longer less than 15. And this is a good way to have, cells divide for X number of cycles or something like that. Instead of having print statements, you can have, your whole program run in there. Another combination, another option, instead of a while loop, is a for loop. For loops have to have, so while tested as long as that condition is true. For loops have a finite set of things that they're going to work through. So here's an example of a for loop. For n in range 5, print n. So we haven't gone over what range does, but let's just see. What is range 5? Range 0 to 5. Okay. Print range 5. Let's try that. Okay. Yeah, it's not showing you. Range 5 basically creates a set of numbers between 0 and the number in there. So range is going to be 0, 1, 2, 3, and 4. So you can do a for loop for n in range 5, print n, and it's just going to embody, so n is going to embody one of the numbers in what we call a collection here, in this collection, and then it's going to move to the next one, and the next one until it's done. It doesn't repeat, it just goes through that collection. So we'll talk about some other types of things you can iterate through with a for loop later on. But yeah, it starts at the smallest and it gains or increments to the next value in the sequence, and then it continues to the end. You can do, range can also do a start, step, and step. So if you want to go from 0 to 9, sorry, 0 to 9 in increments of 2, you can do that as well. So 0, 2, 4, 6, and 8. And that might be useful if you want cells to divide in every second unit, because you have other stuff happening in between. There's all kinds of things you can do with that in CompuCell, which you guys will learn about later this week. Okay, why don't we spend 3 or 4 minutes trying this? And yeah, so I have 11:23. Let's do this until 11:27. So this might be worded a little confusingly. Just work with if A is 100. So as an example, you can start with if A is 100 and B is 200, then your output should be 7,500. So just set A as 100, B as 200, and then see if you can set up your loop to add up all the odd integers between A and B. And inclusively means count A and count B. Okay, I'm going to throw a poll up. If you are still working on it and you don't want us to move forward, indicate that. Otherwise, and we'll decide whether to move on based off of that. And again, this one's a little more complicated than anything we've done. It's completely okay if you can't solve it and just want to see the solution and learn from that. Okay. So I have 11:27, or 11:28. We'll do another minute, and then I'll go through the solution. I know there are a significant number of people who are not doing the exercise. That's totally fine. It's going to be a long week, so spending your energy as you need to makes a lot of sense. Today's exercises are going to be pretty basic, just so you know. We'll kind of introduce some concepts and stuff, but it's really just to teach you all the different kind of tools in the Python toolkit. And so we're not going to do any complex simulations today. Obviously, the rest of the week, you will be doing realistic biological simulations of cell sorting and even more complex than that. But today, if we have time, we might do one simulation of phenomena, but for the most part, it's just going to be the basics of Python. Okay, and with that, my talking there, we've reached 11:29. All right. Oops, that's not what I meant to do. Okay. So I'm going to set A equal to 100, like in the example, and B equal to 200 as my test case. The first thing I'm going to do is if statements to see if they meet these criteria. If A less than B, and I don't know if I told you and specifically, but Well, let's do it without the and. If A less than B, if B less than 10,000. And the reason we do that is because if one of the numbers is over 10,000, it's going to take forever. It's going to take significantly longer to run. So by having two consecutive if statements, it only gets to this point in the code if both of them have been met. Now that we know both of them have been met, we can iterate through them. So we need to start with A and then run through B. So the one way to do this is with a while loop. While, let's do Z, which is a random linear variable. Z so we're going to set Z equal to A while Z is less than B. No, it's inclusive. So while Z is equal to or less than B, we're going to test to see if B is odd. If Z is odd, if Z modulo 2 equals 1, meaning if it divided by 2 and there's a remainder of 1, that means it's odd. And so I hit the enter there and it went to the wrong place. And that's because I forgot the colon there, right? So make sure the colon's there and then it goes to the right place. If Z is less than 2, what we're going to do is we will add Z to some kind of sum. So let's say just some variable equals cumulative sum of odds equals 0. I'm going to start with that as 0. So we're going to say cumulative sum of odds equals whatever that was plus Z. Right? So if it's not a number, it gets added to our sum. And I don't need an else because if it's an even number, I don't want to do anything. And then, so I don't just keep adding it, I have to set Z equal to Z plus 1. And then once it's done with all of that, let's print cumulative sum of odds. All right, let's see if I did this right. Less than or equal to. I just had this in the wrong order. And it printed out as 7,500. So that means it got done right. I want to stop here and ask, are there any questions about this code? Please drop them in the chat or raise your hand or unmute or something. If not, I want to do a slightly different way of doing it. So instead of a while loop, I can do a for loop. For Z in range from A to B. Yep. So we'll be done in just a minute or two. And in this case, since Z is since the for loop automatically increments, I don't have to do the Z plus 1. So let's see how this works. If I do two numbers, I need to do No, the issue was, so the issue says invalid syntax, and it points to where there should be a colon because it's a for loop. Right, so if we compare these two, I'm just gonna make the font a little smaller to compare these side by side. The main difference is the while loop, you have to increment the z on your own. You have to increment the variable on your own, or something else has to happen that will allow it to escape. The for loop has an automatic end, and it automatically does the incrementing because it's going through that collection. So both of those are particularly are valid, but they have slightly different purposes. And once we get into, in the next lesson, once we get into lists and dictionaries and stuff, it'll be obvious which ones to use in different contexts. Last thing we need to learn about is a break. Okay, so Darshan makes a good point. We should use b plus 1, so the sum is also inclusive of b. I didn't get tripped up on that because the last number is it happens to be even, so it didn't get added. But he's right that the second number in range should be b plus 1 because the second number in range doesn't automatically get included. And Dulika, you can look at your code in either the breakout room or during this upcoming break. I want to go over, speaking of breaks, I want to go over what a break statement does. Sometimes you need to end the loop for a given condition. So let's take a look at this program. My sum equals 0 for I in range 5 to 11 by increments of 2. Print my sum is currently 0. If my sum is equal to 5, break. And then my sum plus equals 1. So let's type that out and look at it. So what is this plus equals? We haven't used that before. Plus equals means it's just a shortcut for my sum equals my sum plus 1. As a shortcut for that, we just combine it and just have the plus equals. Okay, so do we have any predictions about what's going to happen here? Based on my understanding of this program, my sum is going to remain 0 because nothing happens, because it only reaches plus equals 1 if it reaches 5, and it's not going to reach 5 because it has no mechanism for increasing. So Control Enter and it prints 0. Now, if I change it to this, if I change the code to this, then what do we expect? What's going to get printed at the end? So now my sum is going to increment by 1 each time until my sum is equal to 5, at which point it'll break. But since we're going from 5 to 11 by 2s, I don't know that we're ever going to get to that. So let's take a look. Yeah, so it stops at 3 because it goes from 5, 7, 9, 11, and it increments by 1 each time, and starts at 0 to 1 to 1 to 2 to 2 to 3. It never gets to 5. But what if we do 19? So now it's definitely, there's more than 5 increments between 5 and 19. So now what this break does is it ends the loop when this gets met. So even if this was 5 to 400, it's still going to end there. It ends the loop. It ends the loop that it's in at that point. Okay, so this is the last slide for this module. For loops, you know the number of iterations. You can end early with a break. You can use a counter. And you can rewrite a for loop using a while loop, which that's more complicated, but we'll get into that later. Well, no, we showed an example of using a while and a for interchangeably. While loops are unbounded. So they don't have, unless you specifically put something that ends it, it can go forever. It can end early via a break in the same way that, that this did. You can use a counter, but you must initialize the counter before the loop and you must increment it in the loop. So here, when we're using Z as a counter, but we have to increment it ourselves and we have to initialize it outside the loop. If we initialize it inside the loop, it'll constantly overwrite and it'll never increment. And not all while loops can be written as for loops. All for loops can be written as while loops. So that's a subtle difference there too. But again, for your purposes, you just got to be kind of familiar with this stuff. So let's take a break. But before we do, let's do this. If I can get you to do one last poll. I've launched it. It's 10 questions, multiple choice. And you can also email us or do a suggestion in the Slack.